looking at the input and outputs, basic input and outputs, Java programming, the use of the C out. So today there are a couple of samples I wanted to look at. So we'll look at one more examples of input and outputs, probably the example 5, which has to do with what we call manipulators. Then I'll talk about example 4.5, I mean, and then we will also talk about example 4.7. I'll talk about that briefly. Okay, and then we'll look at pointers. Okay, last week, I think I mentioned control structures, but we rather look at pointers before looking at control structures. All right, so let's begin. So in C++ programming and other programming languages, there's what we call manipulators. Okay, these manipulators are known as helper functions. Okay, so what they do is they make it possible to control your input and output stream. Okay, using some operators. Okay, so they help you control your input and output stream. Example, as you can see here, we have the set precision, fix, show point, set width. Okay, a whole lot of them. Dex, hex, a whole lot of them. Okay, so these are manipulators you use in writing or controlling your inputs and outputs. Okay. The person with the name ox ... so on, I'm going to take you off to the waiting room, rename yourself, and then join again. Okay. We are supposed to join with your name, not your nickname, not the name of your phone. It's your name and ID. All right, so let's go on. All right, so we are looking at these manipulators. Now, the manipulators fall, like I said, they are function helpers. Okay, so what they do is that they fall under a library. Okay, it falls under a library, and the name of this library is what we call the IO Manip library. Okay, so we include it. We include it as part of your IO stream. You include it over here as part of your IO stream. Okay, so it's the IO Manip library. Okay, so in this library, there are helper functions that help you to perform manipulation. That's possible for you to control how your input and your output stream should appear. Okay, and they work with the double greater than operator, which is the C out, and then the double less than operator, which is used for the C. Now, so today we are looking at how to use these operators. The gentleman with OX, you joined again. I'm taking you off. So rename yourself. All right, so let's go into it. Okay, so this is our first program. We are going to look at how these manipulators work. So we have the scientific, we have the fix, And then we have set precision. Okay, there are a whole lot of them. There are other manipulators. We define them as header files, or we include them as header files. And then you can use them to manipulate your your input output. So let's look at this first example. So I'm going to write it in code so that, sorry, in the dev C++, so that we look at how it works. All right, so we create our new source file. Start with hash include. Okay, or let's first put a comment there. So we are going to give this a comment, and briefly we will say that we want to the use of or using manipulators to control inputs and output streams. So let's look at it. So to start with, we want to include our our IO stream. So hash include IO stream using name space. Then we introduce our main method, our main function. Okay, so in here, we are going to write a couple of programs. Going to write a couple of programs. Okay, so first we declare a variable hours as double. So hours as double, so we can say it's equal to, we initialize it to 35.45. And then we declare another variable as double. Okay, now because as double rate, we initialize it to 5.00. And then we declare our final variable, and we say tolerance. And we initialize it to 0.01, 000, 0. Okay. So we are going to use this manipulators. So we'll use the first manipulator we're going to use is the scientific. We also look at the fixed manipulator. Okay. All right. So we've initialized these three variables: hours, rate, then tolerance. Now we want to output this values. So we are going to use our C out to output it. So we want to output hours. And we'll say the hours equals, so it's going to print out this string. Let me put our return 0 there. Let's continue with the coding itself. So hours, now we reference the variable hours. Then we want to output the rate as well. So we say comma rate. And then the rate is equal to, so we specify the value for rate as well. Then we put there the reference value for rate. So I'll come to the next line. And then we do for pay. So comma pay. Now pay equals, pay will be equal to the hours times the rate. Hours times the rate. And then finally, we'll have tolerance. Which is equal to the value of tolerance. So end line, end line. I hope you can all see the screen.
Yes, sir.
Yes, sir.
Yes, sir.
So this is our C out. Okay. So we want to run this code and see what our output will look like. Then after that, we'll now take this code and then use the scientific manipulator and then the fixed manipulator on it to see how the output, or what will be our output after we use these manipulators. Okay. So we'll compile and run, but first we have to save it. So like I said, you should make sure saving, you have a folder created probably on your desktop with the course code. And it's something you do in exam. So make sure you start practicing it now, how to save into a folder desktop. So I open the folder. This is example 4.2. Sorry, 4.5. So say 4_5. So now it's compiled and running, but there's no error here. All right, so let's look at our output. Can you all see the outputs?
Yes, sir.
Yes, sir.
Okay.
Yes.
So firstly, we said hours. C out hours equal to, so that's this one. Hours equal to, and then we said hours. So this one is going to fetch the value of hours we initialize here, okay, and store that here, which is the 35.45. Okay, that's their value for hours. Then the next one says, comma, this was a string, comma, rate equals, okay, so that's what is given us here, comma, rate equals, okay, in fact, with a space. So it leaves a space after the equal to. That's what we can see here. So rate equals, then rate. So this one goes to pick the value for it, which is 15.00. Okay. So what do you see here with the value for it? Any observation? I want you to observe something before we use the set precision. If you have any observation, you can raise your hand.
I'm not to press anything again.
All right.
It
Rose,
converts down to int.
hello. I said if you want to answer, you raise your hand. Okay. All right. So Rosemary, your hand is up.
The 00 did not appear.
Yes. So for the rate, it was 15.00. Okay, but the 00 did not appear. So that's the first observation from here. Okay. So let's go to the next line. So the next line says, comma, pay. So you can see here that the pay is also showing over here, comma, pay. Okay. Then after the pay, it's showing here as hours times rate. Okay, so it's going to take the value of hours, which is this, and then multiply it by the rate. Okay, so the 35.45 multiplied by the 15.00. Okay, so that will give you the value for the pay. So that's the value we have here after the multiplication. And then finally, we have tolerance. Okay, so it will output the string, comma, tolerance. And then after that, it gives you, or it fetches the value for tolerance, which is this. Okay, and outputs that value. So if you look at it very well, still for the tolerance, you see the same observation that Rosemary mentioned. The values, that's the 00 values after the 1, just like the rates were omitted. Okay, so this is our output for the code. I hope you all follow this output.
Yes.
Yes, sir.
Okay. Now the next thing we want to do, please turn off the video. Those who turn on their video, you distract the class with your use on. So you don't need your video. Just enter your name and index number in the chat and your session, whether part-time, for the purpose of attendance. All right. So now we are going to see how the manipulators work. Okay, so the first one we are going to use is called the fixed manipulator. Sorry, the scientific manipulator. Now, the scientific manipulator changes formatting used for floating point input and output. Okay, so they change formatting which are used for floating point input and output. So if we say floating point, basically talking about values after values with or decimal values. Okay, so how would they change those values? Okay, now it is scientific in the context of making your output look like a scientific value. Okay, what do I mean by a scientific value? For instance, you can make so you see the value with some exponent, okay, sign attached to it, and so on, based on the number of decimal places, and so on. Okay, so times 10 raised to the power something. Okay, Then the fixed is also used in the similar fashion. A fixed is also used the similar fashion. So usually with the fixed, you specify the decimal point. So if it has to maybe 6 decimal places, the fixed will make it 6 decimal places so that the value will still show after the decimal point. For instance, like the tolerate value, sorry, like the tolerance value. Okay, the tolerance value, that values after the decimal points were omitted. Okay, so usually when it happens like that, you are writing a program and you want those values to appear. Okay, but because MATLAB by default would omit those values or those numbers, you have to use these manipulators to control the inputs and outputs when it comes to your program. All right, so let me close this and clear the screen. Then we can continue with the code. What I'm going to do here is to copy this same code again from line 10 to line 12, move a line down, and then paste it. Okay. So we'll look at how we can use the scientific notation to handle this. So I'll just put a comment here, say scientific, so that you can tell that we are now, let me make this raw, let me say the initial values. Initial values. Okay. Then here we'll say scientific notation. Okay, we are using the scientific on it. All right. So with the scientific, you'll see out, let's see out with a small c and put here scientific. Scientific. Then after, we'll see out again and then put here, you should have put the text scientific notation. So after the scientific notation, you want it to now print out the changes, end line, the changes that it will do to our code. Okay. So here we had the initial value, which output we saw earlier. Then here we are going to have the scientific notation when we apply the scientific manipulator to it. So let me just do some quick editing here, make here initial values. So that we can appreciate the outputs we are going to see. Okay. So what is going to happen here is that you realize that on this line, we've introduced scientific, okay, not as a string, but this time as a manipulator. Now, what it's going to do is that because we introduced it before this statement, it's going to affect this C out over here. Okay. It's going to affect it. All the C out we have coming under it. So let's compile our code again and run it and see what output we get. So do you see what's happening from our output?
Yes, sir.
Yes, sir.
Yes, sir.
So first and foremost, our value for hours, okay, was the initial values was 35.45. Okay. Now when we use the scientific manipulator on it, see what it's giving us now with emphasis on the exponentiation. So it's like we're saying 3.456, okay, times 10. So the exponent there is what are you saying? Times 10 raised to the power 1, 001. Okay, so that's 1. Okay, so that is what it's giving us. But we come to the 15, it's doing it what? 1.5 times 10 to the power 1. So you move 1 decimal point. So you move like 1 decimal point to this side, and that will give you this value. When it's a 15, move 1 decimal point here, and that will give you a 15. I hope you all get it.
Yes, sir.
No, sir. I still don't get it.
Sir, please, no.
This is simple number. What's the term they used? I've forgotten the terminology in basic maths and elective maths.
Standard form.
What's the name? Someone should help me. So in mathematics, if you have maybe a number 1.5 times 10 raised to the power 2, what it means is that 1.5, you move it what? 2 decimal places to the right. So this will give you 150. Okay, 0.00, or whichever way you want to write it. It's standard form, eh? Is it standard form? I've forgotten the.
Yes, sir.
Yes,
Standard form.
Okay, all right, thank you.
Yes, sir.
Please, the person with the name, this guy. Anytime I put you off, you join again. This guy, .ox. This time around, I'm sending you out of the class if you can't rename yourself. So please, anyone who joins the class with a weird name, I will send you out. All right, so let's go on. Okay, so that's what we are seeing over here when it comes to using of the scientific manipulator. Okay, so if you look at this one too, you can see the value after the scientific manipulator, 5.317. Okay, 5 exponents, that's times 10 raised to the power 2. That means when you move it 1, 2, the point comes here. So you can see the point is coming after the 1. Okay, then we have the tolerance to in this form. Okay, times 2 raised to the power what? -2. -2 means that this time you move to the left. So 1, 2. So that what is given at 0.01, as we can see here, 0.01. Okay, so that's how the scientific manipulators work. Okay, so there are times you may have a problem and you are working with values which are like this. Okay, and it's best to represent them in the scientific form in order to continue with your computation or whatever problem you're solving. So all that you do is just introduce this scientific, just introduce it before your C out. And then what will happen is that it will change all the values after it, all the C out values come in. Right? In fact, you can use it for the C in as well. Okay, so you change all those values to a scientific value, okay, or all you call the standard form. Are we all here?
Yes, sir.
Yes, sir.
Gideon, you have a question?
Yes, sir.
Yeah, go ahead.
Sir, please, I want to ask that, let's say if you are writing the code, can you go straight forward to introduce the scientific notation, or you have to write the initial ones before you come for the second part that you just did?
No, so if you know what you are up to, you can go straight ahead and then write it because you know that, okay, this is what the scientific notation does in your, or the scientific manipulator does. You can go straight ahead and then introduce it. Okay, but what I'm doing here is to explain the initial value so that you see the context. Okay, how the values will look like with decimal values. And when you use the scientific, how it changes those, or how it manipulates those values. You get it?
All right,
So
sir.
if you are working with something like that straight away, you know that, okay, this computation or this problem I'm solving, I need scientific values. I need to represent them as scientific values. Then you go ahead and write them in that form or output them in the scientific form.
All right, sir. Thank you.
Welcome. Okay, so let's look at the next one, which has to do with the fixed. That's the fixed. So it's the same thing. So this time I'll just take scientific here and put here fixed notation. Don't want to edit it that much. And then change here to fixed. Okay, so just before you see out. Okay, so you realize that all the C outs that came before the fixed, they were not affected. But those that come after it would be affected by the fixed manipulator. So I'll just put here fixed manipulator. Then compile this code, run it again. So let's look at this as well. Okay, so we have the initial values, which we are all previewed to, as we can see on top. And then we have the fixed values. Now, what do you see? What do you observe about the fixed value? You can raise up your hand and speak. What do you observe about the fixed? Yes, Paul.
Sir, please. I think about the fixed values, it increased the decimal numbers
To how many decimal places?
to 6 decimal places.
6 decimal places. Exactly. Okay. So as you can see, from the default value or the original values or the initial values, the number of decimal places for the fixed is 6. Okay. So it increases all the values to 6 decimal places. So even if it's 10 decimal places, it will bring it down to 6. Because what? That is how the fixed manipulator, okay, functions. That is how the fixed manipulator functions. Let me see if I can do another one. Okay, so these manipulators we are talking about, the end L, okay, the end line, which we've been using so far, is also one of the manipulators. Okay, it's one of the manipulators. There's also other ones like set space. You can go and search online for them. Set space, okay, and a whole lot of them. Set fill. Okay, a whole lot of them. Set precision. Okay, so let me see if we can look at one example, one more example, and then we can move to the next. Sorry, one more manipulators in this regard, and then we can look at another example. All right, so let's look at set precision. Set precision. So I'll clear. Let me copy this. Okay. Paste it here. So this time I'll take this out. Let's look at how the set precision works. So the manipulator name is set precision. So you don't have this in your handout, so just pay attention. So, all right, so the set precision is also used to control precision, or it's a precision parameter which is used in the input and output stream. Okay, so it's mainly used in your, like I said, your C out, then your CE. So for instance, if I take, let's say, the hours, if I take, let's say, the hours, I want to set the precision of the hours. And we know that the hours, so what I'll do is, so unlike the fixed, where you put it at the beginning of your statement, in fact, let me even move this out so that the fix will not affect it. Okay. I'm moving it up so that the fix won't affect it. So here we are doing set precision. Set precision. So with this one, what you do is you put it inside the, or just before you, the value you want to output. Okay, so you put it in there so that it affects it. So for instance, we want to output the hours. Okay, so set precision. Okay, or we can even, let me put it after it. So just after this, I'll put here set precision. Now the set precision always takes a value. So you put it in decimal bracket. Then you give it a value. You give it a value. So for instance, I give it a value, let's say, what number should we use? Let's say 1. I give it 1. So when I run, okay. Now, so when I run this code, it's giving me an error. Okay, it's giving me an error. And it's saying here that error, set precision was not declared in the scope. Please, can you all see that? The error
Yes,
message
sir.
is that here. Set precision was not declared in the scope. Okay. Why? Because unlike the fixed and the scientific, okay, for the set precision and other ones, since they work like on one-on-one basis with your output, not like take the entire output. Okay, what you have to do is you have to introduce that IO stream here, like I said in the beginning of the class, the IO manip. You have to include it here. So hash include IO manip. Now this is acting more like a function. Okay, the set precision is acting more like a function. So it's going to take a value as an argument or as a parameter in here. That's why we have the brackets. Unlike the previous ones, we don't have any brackets. So like you saw with the fix, when we introduced it, we didn't put any bracket there. Okay, because it doesn't work that way. But for the set precision, Collins, stop writing on the screen. So for the set precision, you put it there. Okay. So I'll run the code again. Collins, stop writing on the screen. Undo whatever you've done. Collins. So we'll compile and run it again. So you can see I've added the IO money. Okay. So compile and run. So this time there's no error showing. So this is our value. Okay. So because we use the set precision, okay, it has changed the value of our fixed because we use the set precision to 1 decimal place. Okay. So you can see that now the fixed values are to 1 decimal place. Okay, because we've used the set precision to handle that. Now, let me just do a change of position of this code so that you see exactly what is happening. So I'll bring the fix here before the set precision value. So you can see that when I did the reordering, it shows what I want to explain now. So you can see here that first, the hours is showing us what? This is the initial value, 35.45. Now, when we use the fixed, gave us what? 6 decimal places. Now, when we use the set precision is now overriding the value, okay, and making it to what? 1 decimal place because of what? the one we put here. Okay. So it changes all the values to one decimal place. Okay. Now I'll go back and change the set precision value to 0. So when I change it to 0 and run the code again, it's going to change it to a whole number. So this time changes the values to what? A whole number. Okay. Now, if you look at it carefully, it is rounding up the values. How you can all observe that? Looking
Yes,
at the
sir.
initial
Sir.
value,
Yes, sir.
looking at the initial value, you can see that the initial value is what? 35.45. But it's rounding it up based on the 4, which is less than 5. So it still remains at 35. 15 is 15. 531.75 because of the 7. It makes it what? 532. Okay. So this is what the manipulators do in your program. Okay. They influence or control the output and input values you get. Now it can also work on text as well. So it's not only about numbers, but there are some that also work on text. Okay. All right. So I see some hands up, Paul and then Philip. Let me take your questions and then we move to the next example. Yes, Paul.
Sir, please, thank you very much. During your speech or during your time of lecturing, you first of all said you want to bring the set precision first so that it will not affect the fixed notation, but it affected it.
Yes, but what happened is that it affected the fixed notation. Okay, when the fixed notation comes after the set precision, so it's hard to override the fixed notation, the fixed manipulator. Yeah. So the value of the fixed manipulator changed.
Okay.
Yeah. So what they do, they have functions that override other functions. So you have to be careful where you place them in your output.
Okay. Well understood. But sir, please, does it mean that always the fixed notation should come before the set precision?
No, not always the case. Like I keep
Okay.
saying, it depends on what you are doing. The
Okay.
example you are doing. For instance, if I'm writing a program and it will require that I set all my values to 2 decimal places. Maybe I'm doing something regarding a bank application or maybe a shopping mall application. You know the way this e-commerce and online shopping sets their values to 0.99, 0.99, 2 decimal places. Okay.
Yes.
If I'm doing something like that, then using a set precision with a value here as 2 will mean that all the currency values I'll use in my program, or salary or whatever, or bank or whatever, money I'm going to deposit, everything will be in 2 decimal places.
Okay.
You get it?
Okay. Yes, please.
So
Thank
within
you.
that context, I can use the set precision to manipulate or control my output variable when it comes to working with money.
Okay.
If you are doing scientific something, you can use the fixed. Maybe you are doing something regarding what example can I give? Maybe a scientific program. You are writing a program for some chemical balancing, whatever. where the values, in fact, the precision is important. So, for instance, the decimal values points, whatever, maybe to 6 decimal place, 7 decimal place, you need to capture them in your computation. Okay, so with such type of problems, you don't need to round them up to maybe 2 decimal place or 3 decimal place. You want to take the value as it appears and then work with it. So the fixed and the scientific, so on, would also work in that context. Okay, so you can go and read more. I'm going to read more on some of these manipulators. All right.
Okay. Who's the last question?
Hey, my brother.
Okay.
Okay, you go on with your question and then let's listen to it.
Sir, please, I'm sorry if you have already spoke about it. Is there any hashtag to include in the code to be using the set precision and the fixed manipulator?
No, with that one, they all fall under the IO manip. The hash include, not hashtag.
Oh, okay.
Yeah.
Hash.
So they all fall under IO manip. I mentioned it earlier. Okay. But with the fixed one and the scientific, it wouldn't give you, in fact, like I said, the end line is also part of these manipulators. Okay. But because those ones do not come with a bracket where you have to enter a value, as you can see with the set precision, you can use them without including this and they will work. Right? The way the end line works, the fixed also works, scientific also did. But when it comes to set precision, set fill, set base, and so on, you would have to enter a value inside this bracket. So because of that, you need to include this so that to recognize it as you introducing a function with a value in there. Okay. And like I said, one of the topics we look at is functions. So all this will be explained, or once we talk about functions properly, appreciate some of these explanations.
Okay, thank you very much, sir.
Okay, welcome. Yes, Philip.
Okay, sir, please. I wanted to ask, like, if in the case of exams or maybe in the real world, then maybe you wanted to use the set precision instead of the fixed notation and the scientific notation. Maybe like the fixed notation is somehow giving is giving the five decimal place. And I wanted to ask if will it be good if you use the scientific the set precision instead of the scientific notation and the fixed notation?
I've answered this question already. Like I say, it's always based on the value you want to display or the output you are looking out for. So that's why I said go and read on some of them. There are a whole lot of them. If you Google, you see a whole lot of them. Okay, some for characters, some for numbers, a whole lot. They all fall under the IO manipulators. Okay. So
okay, sir, thank you.
depending on the problem, if the problem is a scientific problem and you need to output the value with the exponent and all that, then you know that, okay, with what I'm doing, the best manipulator I can use to achieve this output is a scientific manipulator. So you use it so that you can see the exponent value, the exponentiation of whatever value you have.
Okay,
All
sir.
right.
Thank you.
Welcome. Bright. So I'll take the question from Bright, Bashiru, and then Jacob. Then we'll move to the next example quickly.
Okay, sir, thank you very much. My question is, if I want to display something like our index number, is there any manipulators that can help me display both digits and then characters?
What do you think? As for this one, we've talked about it already. Index
Sure.
number. We mentioned it in previous lectures. Even last week, I remember I mentioned it. Your index number is already a string, so you don't need any of these manipulators to handle it. Unless maybe a manipulator like set weight, which would set the size of the index number so that you should set it as 10. Or what's your index number? What values? How many characters are there? Is it 9? I
Okay,
think
it's
9
9.
characters. Yeah.
9.
So you can set it as set width or set one of the manipulators. So set the width to 9. That means the length of the characters should always be 9. So, but it's you don't need manipulators for index numbers. So all you need is the use of a string. It's a string because a combination of characters, whether numbers and letters, is a string. Okay. All right, let's take Bashiru.
Okay, sir, I wanted to ask why didn't you terminate the line 12, which is the end of the sentence, the rate, and then line 13, the taller one?
Okay, all right, that's a good question. So it's the same output, okay? So because if I continue typing, it will appear here, very long. You see it. It's still the same output. This is how it's going to appear, very long. And because I want you to see what I'm typing, I want to break it down into lines. So instead of having this whole C out being this long, I just come in between the extraction operators, the insertion operators, and then break it into different lines so that you can see whatever I'm doing. But at the end of it, the C out is actually ending here. This way is terminating. You get it?
Yes, sir.
So it's because of how lengthy the output we want is. So instead of writing it on the same line, I want to break it down so that you can all see what is happening. So let's
Thank
take
you
the
very much.
last question from Jacob, and then we continue with the next example. Jacob, unmute and ask your question. All right, Jacob is not here. Then let's move to, okay, he's speaking now.
Okay, sir.
Yeah,
Okay, sir. Sir, thank you very much for the opportunity.
welcome.
And sir, please, with a fixed notation, sir, please, I want to know why you didn't, the fixed notation. Sir, I want to know why you didn't put it in strings.
This one. No, Jacob. Austin, stop writing on the screen. Austin
So I
Daku.
think he's talking about line 17.
Austin Daku. Undo whatever you've done on the screen, else I'll take you off this platform.
Undo.
Let's continue. Yes, Jacob, what question were you asking? All right, so let's go on with, we'll come back and take other questions. We want to look at more examples. Okay. All right, so example 7.4.7. Okay, we call that the post-fixed increment and pre-fixed increment. Okay. Now, in programming, we have what we call increment. Okay, increment. There's the increment. For instance, if you want to say, number equals 0, or let's say int number equals 0, and we want to increase, let me just make it int x equals 0. I want to increase the value of x, like increment. I'll say x is equal to x plus 1. Okay. Now this x is equal to x plus 1 simply means that x is equal to 0, because the value of x is what? 0. So 0 plus 1, and that will give you 1. So the new value of our x is equal to 1. Okay. Now, if I want to continue increasing this again, I'll say that x equals x plus 1. Now, the new value of our x, okay, is this 1. So that will give us x equals 1 plus 1. And that will give us what? 2. Okay. Let me add a third example to it. So when we say x is equal to x plus 1 again, what it means is that this x is now 2. That's a new value of x. So we are going to get 2 plus 1, which is equal to 3. Okay. So if you look at this critically, you can observe that the value of x keeps increasing. It was first initialized to 0, then 1, then 2, and then now 3. Okay. So what is happening? The increment is what? Plus 1. It keeps increasing, plus 1, plus 1, plus 1. Okay. Now, what is this pre-increment, a post-fix increment, and pre-fix increment? Okay. The post-fix increment, what it means is that, for instance, instead of writing x is equal to x plus 1, this post-fix increment will be written as x plus plus. Okay. To now be written as x plus plus. Now this x plus plus, we call it postfix. Why is it postfix? Because the operator, the plus plus operator, comes after the operand x. Okay. If you want to know what operands are, go back to the videos on operator precedence and associativity. I've explained that there. Okay, so the plus plus operator comes after the operand x. So this plus plus, x plus plus, is the same as you saying x is equal to x plus 1. The same as you writing x is equal to x plus 1. Then it becomes postfix, prefix rather, when you say plus plus x. So at this instance, your plus plus is coming before your operator. So this is called pre-increment, and then post-increment. Are you following?
Yes, sir.
Okay.
Yes, sir.
So what it means is that you are adding 1 to the value of x. So if x is 20 and you say x plus 1, it means 20 plus 1. If you say x plus plus, it's the same as you adding 1 to the x. Okay, so it works with increment and decrement. It works with increment and decrement. So if you want to decrease, it's just you saying x is equal to x minus 1. So the postfix will be x minus minus. The prefix will be minus minus x. Okay, so please take note of this. You'll be seeing more of them as we go along with some of the examples, especially the topic we'll do next week. That's the control structures. You see it more when we are doing loops. All right. Another way in which you can write this x plus 1. Another way is to say x is equal to and then plus 1. Please, you all see that x equals plus 1. It's the same as you saying x is equal to x plus 1. So there are many ways we can do that. Okay, once we get there, you familiarize yourself with it. Or if you have already reviewed, I've been seeing some of this in some programs. Okay, so they all mean the same thing. You're doing x plus plus or x equals plus 1. Just saying add 1 to the value of x. Okay, there are times where it does with multiplication. So it will say x equals asterisk, that's multiplication 1. Okay, or sometimes it can be 2, it can be 3. If it's 2, it means plus 2, and so on. Okay. All right, so I'll not write out example 7 code, but I want you to try it yourself. Now, there's something unique that is happening in example 7. Okay, I hope you all understand what I've done here with the plus plus
No,
and then the plus 1. Okay, if you
no.
don't understand, go back and watch the video again when it's uploaded.
Yes,
So
sir.
that if you want further understanding to it, then try out example 4. Now, let me explain example 4. Okay. So what example 4 is doing is that this example is trying to implement the postfix, which is the x plus plus. Irene, stop writing on the screen. Irene, undo whatever you've written on the screen. Thank you. And then the plus plus x. Okay. So the x plus plus, we said is postfix. post, then the pre is plus X. Now, let's look at the code. So it says hash include IO stream, which we know what it does using namespace. We know what it does. Then our int main. Okay. Now, a variable has been declared and initialized to 0. So I hope you can all see that. It's saying
Yes,
int
Not
x is equal to 0. So initialize x with a value 3. Then this part is demonstrating what? Prefix increment. That's this. This is a prefix increment. Okay.
It's
So,
post.
sorry. Thank you very much for the correction. It's postfix increment. Okay. So this 3C out here, okay, is what is going to use to demonstrate it. Now, it says the value of x before incrementing. So it outputs x. Then the next value is said post incrementing x. So it does x plus plus. Okay. So the first one will print 3 when you do the value of x before incrementing. So this is the value of x. We all know it to be what? 3. So before you do the incrementing, that's the x plus plus. We all know the value is still what? X, which is what? 3. Then it comes to the next C out. It said post incrementing x. Post incrementing x means you are doing x plus plus. Okay. So post incrementing x, it gives us 3 again. Okay. It prints out 3 with the x plus plus. Now, then it comes to the next C out, which says the value of x after post increasing or incrementing is, now this time it gives you 4. Okay, meaning that this post increment has a unique way of working in the sense that it doesn't post increment immediately here. Let me change the color so that you can see. The post increment doesn't begin immediately here when you do the plus plus. No, it rather works after the next output, which we can see here, giving us 4. Okay, that's the post increment. So it works post or after the increment is done. Okay, or when you output that value again, then you see it appear. Then the pre-increment, let's talk about that also. So we have the pre-increment here. Okay, they are all going to do the +1. Irene, please, don't be using your pen right on the screen. So let's look at the pre-increment. So with the pre-increment and the post-increment, they work the same. They are all going to increase your value. Okay, but it all depends on where the value appears in your program. Okay. So for instance, this one says the value of y. So it's initialize y to 5. Okay, the value of y before pre-increasing, same as y, which is what? 5. Okay. Now, pre-increasing y, and it does what? Plus plus y. So this is like saying 1 plus what? Y. Okay. So with the pre-increment, it increases the value once you display it. Okay, once you are doing the pre-increment, even before, okay, sorry, even before you go and output it. It's already done the pre-increment. Whereas the post-fixed increment, okay, will do it after you output the value or after you output that variable again. Okay, so with the pre-increment, which was done here, you realize that the number was still 3. Okay, but when you come to the pre-increment, which is done here for the y, instead of 5, now we have 6. Okay, meaning that the post-increment actually affected the variable when we introduce the C out again, and then what? Reference the variable X. That was when the post-increment affected it. But with the pre-increment, immediately you use it, it performs the increment. Okay. So I want you to try out this example and then go online and read more about it. Okay, how the post-increment and pre-increment works. Now we are going to use them in our next topic. A lot of that. Okay, so get the understanding, and then we can move on from there. Okay, so we have some few minutes left. Let me talk about pointers quickly, and then I'll give you the opportunity to ask your questions. So pointers, okay, pointers is one of the elements in C++ and C programming, a very, very key element in C++ and C programming, mainly C and C++. So what does it do? What does it do? Pointers. Okay, just briefly talk about it, and then we'll look at an example. All right, so pointers are used to store the address, okay, the memory address of a variable. Okay, or for instance, I'll say anytime you declare a variable, so you say maybe int x, okay, what it means is that you have this memory location, laptop memory, and then you are saying that this session should be reserved and given the variable name x. Okay, so this section of your memory, so let's say this is your memory, computer memory. Okay, so you are saying that this part of the memory should be reserved for a value. Okay, but this x here is your variable, and you are saying the x should be an integer value. Okay, I explained this from the last lecture. If you watch the video, you would appreciate what I'm explaining here. So at what point does a pointer come in? Now the pointers are used to get the memory address of the variable, where the variable is being stored. Yes, we know that, okay, a container or a place is made available in memory to hold that value. Okay, but what is the memory address? It's like saying that you are showing someone that, oh, this is my house. This is where I live. This is my house. Anytime you are looking for me, come to this white building. This is my house with the nice gates. This is where I live. Okay, so everyone knows where you live. But actually, what is the address, house address? Do you get what I'm saying? What is the house address? What is the, maybe, now we'll say GPS code. of your house. Yes, this white building with the black gate is your house. So the white building with the black gate is like you saying the variable X. Okay, and you are the value, you live in that house. But we want the address, the memory address of your house. The memory address of your house. That is what a pointer does. Okay, so the pointers fetch the memory address of the variable, where the variable is stored in memory. What is the address? Okay, what is the address of that variable? So he said a pointer variable is a variable whose content is an address. Okay, so we know that yes, we've declared the variable as X, and then a location is created in memory for that variable. But what is the address of that memory? Okay, so that is what pointers helps us to do in C++ program. Now, this is very unique because it's only C++ and then C programming that use pointers. Okay, so when you go, usually a course like data structures and algorithm, when you go further, you learn more about it. Mostly it is well taught with C++ because we are able to distinguish between what a pointer is doing in the program and so on. Some of the concepts is best explained when using pointers. Okay. Whereas other programming languages like Java, C++, and all that, the memory allocation is done dynamically. Okay, such that you don't have to do memory allocation directly and so on. Okay, yes, memory allocation directly or reallocating memory. Okay, but when it comes to C++, when you are doing data structures and algorithm, which has to do with how you organize and store data when you're writing programs, okay, C++ uses pointers a lot. So it helps you understand that, okay, this, you want to push this value to this particular variable. Now, what is the memory address of that variable? Okay, allocate it to this particular memory address, not the other one. Okay, so with pointers or in C++, it's more specific, more direct, more specific. Okay, but Java and other programming languages, it is more dynamic. It doesn't talk directly about how the memory allocation is, okay, whereas the use of pointers does. So let's look at a few examples, just one example, okay, because it's straightforward. Straightforward. So we'll look at one example and then I'll take your questions. All right, so let's look at this example here. I'm going to type it out in dev C++ so that we all get what is happening. So I'll create a new source file. On this new source file, we are going to include our IO string and then start writing program. All right, so hash include IO string using namespace main. So we'll say int. So how do we declare a value as a pointer variable? Now we use the asterisk. Someone will say, but we use this asterisk for multiplication. Yes, it's for multiplication operator, but it's also used in pointers. It's also used in pointers. In terms of pointers, if you look in your handouts, you see it over there as what we call the three. You see it as a dereferencing operator. Okay, it's a dereferencing operator. So there are two main operators we use in terms of declaring your pointer variable. You use the asterisk symbol, okay, before your data type. So the data type, the asterisk symbol. And then this is an example. Then we also have the address of operator, which is the ampersand. Okay, that's used to get the address of. Okay, so it's a unary operator that returns the address of its operand. So this is how that is also declared. And then we have the dereferencing operator, which is the asterisk. So back to our example. So P, int P. So what we are doing is here is we are declaring a pointer variable. Declaring a pointer variable. Then we want to declare another variable, say X. And we initialize X to 37. Now we want to see out. So we say see out. And let me do it in lines. Let's do it in lines so that you appreciate the output you are going to get. So line 1. Sorry. In line 1, we say X is equal to. Now what is X equal to? We reference the value of X. Then we say end line. Now when we finish, we come and say P. And we know P. P here is the pointer variable, P. Okay. So we say P is now equal to ampersand X. And we know the ampersand as the we know the ampersand to be the operator that returns the address. Okay. It returns the address of the operand. Okay, so the value. So our value here is X. Okay, so it's a unary operator. What it's doing is that it's going to return the address of X. That's what we are doing here. Now, when it returns the address of X, it can store it in P. Why can it store it in P? Because we have made P a pointer variable. Pointer variable meaning that it can store address, it can store memory addresses. Okay, so how do we get the memory address of the value X? X has a value of 37. We can only get the memory address of the value X by introducing the ampersand to it as a unary operator. Then this ampersand will now fetch the address of X. Okay. Fetch the address of X. And then now store that value in P. Store the value or store the address. Let me put it this way. Address of X in P. Okay. So let's continue with the program. So we say C out. So this time, what are we C out in? Let me just copy this and edit it quickly. C out line 2. So line 2 is asterisk and P. Okay, asterisk P. Now, what is asterisk P? Asterisk P is equal to asterisk P. Okay, and then, sorry, asterisk P, and then we'll put there, let me just copy these lines quickly. Asterisk P, then we say comma X. X is equal to X. So let me run this first line, 2 lines, and see what is happening. So you can, sometimes they appreciate the output helps you to appreciate whatever we are doing. Sorry, I made a mistake here. This equal to should be in here. All right. So compile and run. I'll save this as example 5.1, 5_1. All right, do you all see the output?
Yes, sir.
Yes, sir.
So let's look at what is given as this output. This output. So you can see first we declared a pointer variable. Pointer variable meaning that it's going to store memory address. You get it? It's going to store
Yes, sir.
memory address. Okay. Then we initialize X as what? 37. So that was what we've done in line 1. X is equal to 37. Okay. Then in line 2, we are saying that P is equal to ampersand X. Now this ampersand here is supposed to fetch the address of X. Okay, so X is 37. So the address of 37. But we said P. Okay. Now, when we come back here, we said star P, okay, is equal to star P. Okay, that's a pointer variable P. And it's giving us what? 37 again. Okay, so take note, is we have now equated the value, the address of X as P. Okay, but this is the referencing. So the referencing is giving us the value within the P. Okay, so the value within the P, which is the same as 37, and then X as 37. Okay, now let's go on with the code. So we move to the next line. The next line says star P is equal to 58. Okay. And then now we see out line 3. So I'll just copy this again and then paste it. And this time you say line 3, sorry. Copy, paste, say line 3. Okay, EX, the same thing. Then we output our X. Okay. Then now let's move to line 4. So line 4 is saying that address of P is equal to address of P is equal to, now we use the asterisks here to fetch the address. Okay. So we fetch the address of P. Then line 5, we say the address, sorry, the value of P. How do we get the value of P? The value of P is P. And then line 6, we want the value of the memory location. Okay. So value of the memory location. How do we get that? We can get that by specifying the value as of the memory location pointed. Okay, let me just continue it here. Memory location pointed to by star P equals star P. That is not, so this way, and make it smaller so that I can fit it to this part. Then we have line 7. So line 7 says the address of X. So X, to get the address of X, we use the star or the ampersand and then the X. And then finally line 8 is asking for the value of X. Sorry. Value of X. The value of X, put here X. Okay. So let's run this code, see the output, and try to relate it to the code we've written. All right. So let's look at the code and what is happening. Okay, so we start with line 1, where we said it should print out the value of x. It should print out x, so x was 37. Then line 2, where we said p, okay, it should print out p, and then print out x, so it created a value to it. Then line 3, so line 3, you notice that before line 3, we did a new value of, we gave p the pointer variable p, we gave it a value of 58. Okay, so x is now 58. Okay, so notice, let me just draw this. We declare the variable, we said the variable is x. Okay, and we declared a pointer variable, which is p or asterisk p. And we said p is equal to ampersand, pardon my drawing of ampersand x, ampersand x. Let me use the green for the x so that you can see it clearly. And x. Then now we are saying that px, sorry, star p is now 58. Star p is 58. The x, we gave it what? 37. So what it's saying here is that this ampersand x, what it's doing is fetching the address of x. So if we say the address of x is x11, x22, if that is the address, then we are saying that p should now assume that address. Are you following me?
Yes, sir.
Okay, so if the address of x is this value, then what we are saying is that this value address should be given to p. Okay, so if it's given to p, and now we are saying that star p is 58, then x will now be what? 58, because they are using the same address. They are using the same address. Okay, so p is like me saying that, okay, or x is like me saying that this is my, or I live in this house. Okay, then p is my brother. Then my brother is saying that my house address, or my brother, or let me use you. So you are saying that your house address is my house address, even though we don't know my house address. Okay, so you being P, you are saying that your house address is my house address. So now someone is coming to deliver something to you, which is this value 58. Okay, so if that person, the delivery person comes, because you have given that your house address is my house address, referencing the ampersand x here, this value 58 will go to P. But even though it's going to P, because it's coming to my house, where this case P and X are sharing the same address, that means that instead of 38, the value will now, sorry, 37, the value will now be 50, okay, in there. So that is what is happening there. Okay. So you can look at it carefully. So that's why we have px as 58 and x as, sorry, asterisk p as 58 and x as 58. Now the next line, which is line 4, it says address of p. So now it's fetching the address, it's returning the address. That's what the ampersand here is doing. It returns the address. So this is the address of P. Okay. Now, the next line is saying value of P, line 5. And we put P there. Okay. Now, value of P, because now we've equated P, okay, we said what? P is equal to what? P is equal to ampersand X, where this ampersand X is the address of X. Okay, so we can see clearly here that P and X are assuming, sorry, the ampersand X. Let me do it so that we can all flow. Okay. So what's happening here is that the value of P is now that memory location. This is the P here. And we said P is ampersand X. So if P is now showing you that, okay, the house address of X is where I am, then the value of P, okay, is now what? The house address of X, okay, or the memory address of X. Then we go further. It says the value of the memory location pointed to by P, that P. Take note of. There is star P and then there is P. Okay, so star P, the value pointed by star P is 58. That's the value, which is this one. Then the address of X. So you can see now the address of X again. Okay, the address of X is the same here. Then we have the value of X, which is what? 58. The value of X being 58. So that is how pointers were barely fetching the address of a variable. They were pointing to the address of a variable in memory. This might sound a bit complicated, but I believe when you get more examples and you practice with it, you get basically what it's doing. Maybe it's the example, but basically what it's doing is that to fetch the address of the, you want to get the address of a variable. So if I want to get the address of this, all I do is that, let me just comment this out. Okay. So if I want the value, the address of X, simply put, if I want the address of X, all I'll do is I'll put ampersand here. Okay, so X is 37. So if I want the address of X, all I'll do is just put ampersand here, and then this will give me the address of X. Okay, so mainly that is what it's doing. Okay, so in case the code looks plenty in your face, that is what it's doing. So if I put the ampersand before the X to give me the address of X. Then this address of X, I can say that my X, okay, is the same as my, or equates that to my P, okay, or the reference P, the pointer variable P. Relate that or equate that to the X, and they will all be fetching the same address. All right, so we'll end it here. It's past 7 o'clock. Let me take just 5 questions. Just 5 questions. I need to go through something with you quickly about the LMS. So just 5 questions. 3 hands are up. Okay, the 4th one, Daniel. So the 5th one, if you have a question, just raise up your hand. Yes, Eric. So let's take these 5 people, starting with Bright, and then we'll end with Eric. Yes, Bright.
Sorry, that was a mistake. I mistakenly
Okay.
left my hand off.
Okay, so let's go to Emmanuel. So we start with Emmanuel and end with Ferdinand. Yes, Emmanuel, do I unmute and ask your question? Okay, Emmanuel is not ready. Let's go to Bashir.
Okay, sir.
Yes, Bashir, if you are ready, ask your question. Okay, it's also not ready. Let's move to Daniel.
Hello, sir.
Yeah, I'm here. I'm here.
Okay, ask your question.
So I wanted to ask, when you compile and run the program, the value of S and P changes to some letters. I don't
Yes.
understand why they did change that letters. Yes.
Okay, so those letters you saw there were the memory address. So anytime we say memory address, the values you saw, let me run this again. That is a memory address. Okay, so for instance, we know X to be what? 37. Okay, but because we want the memory address, like in memory, if we go into the computer's memory, where exactly are we going to find X? Where? So I come to your area, you say, oh, your area, your house is the white house with the black gate. Then I get there and I see so many white house with black gates. So be specific. Being specific means that, okay, this is my house address or GPS address. So the values differ in memory as and where they are given. So it's not like it's a specific value. If I run it again, you see that the value will change. Okay, so it's being occupied in various places in memory. Are you here, Ashiru? All right, so let's take the next question, Daniel.
Hello, sir. Thank you for this opportunity. I want to ask, I've noticed that all your examples, they are not questions. So I'm asking whether maybe in an exam or a quiz, how are pointers asked in a question? Or there is nothing like that.
Oh, so for instance, if I take this example, I can ask you, maybe I'll do up to line 4. Okay, this is line 4, right? And then I'll ask you, what is the value? What is the value? So reading the code all the way to where the C out line 4 is, I can ask you, what is the value of maybe line 4. Okay, or what is the value? Because it will be a memory address, okay, which you can't tell unless you have run the program to fetch that address for you. You can't directly tell that, explicitly tell that this is the actual address, okay? But in certain contexts, like maybe what is the value of this P? So I give you the code to some extent and ask you what's the value of star P? And you say, okay, star P is equal to 85. Do you get it?
Yes, sir.
So something like that. But mostly, depending on whoever is going to teach you data structures and algorithm, if the person is teaching it in line with C++, then you see more of this in that course. Because that course is just to show you how data is organized and stored in a program. This is just to give you a foundation to pointers. So data structures and algorithm, they are going to teach you the key things you have to do with some of these concepts. That's if the person is using C++ to explain. Then things like pointers, you need it to understand, okay, if I write a program and I want to push it to this memory location, the data structures there are so many data structures. So as and when you are using a particular data structure, there is a way in which you store the data. And in C++, if you understand that particular type of data structures and are using C++, then you know that, okay, I have to store it this way. For instance, there is something known as linked list. Okay, linked list, when you declare the linked list, it's a data structure that has 2 parts. Okay, one part is the data that you are storing, and the other part is holding the address or the link to another data. So it's linked up in this form. Okay, so it's holding the address to another data in that order. It's like you arranging maybe students in a classroom. So you are seat 1, you are seat 2, you are seat 3. Okay, and you can tell that there are empty seats in the classroom. So I'll say, okay, you go to seat 1. So I'm moving you to maybe seat 1. Then I'll say you go to maybe seat 24. So that seat 24 there is the link or the address to that particular seat. Okay, so in data structures, you push, it goes beyond just the normal declaration of variable and then that is all. But you push it to specific location. Okay, so that is how they work. So there's more to it, but this is just the foundation. Yeah, this is just a foundation. So let me take the next question. Ferdinand. Someone's Ferdinand.
Okay, sir.
Yeah.
So please, what's the difference between the address of operator and the reference operator?
The address, let me move to the slide so that address of operator and the reference operator. Okay.
Yes, sir.
So the address of operator, that's the ampersand. What it does is to return the address of the operator. Just like we saw with this example, the address of the variable, I mean. So just like we saw here, X was 37. But when we put the ampersand before the X, it does what? It brings out the value, or it brings out the address of X. Okay. Now, in declaring the variable, you declare it with asterisk, that's the reference operator, it's P. Now, what it means is that you are saying that there is a position, a location in memory, which you store a which can also store the address of another variable.
Yes, sir.
Okay, so that is what this means, the dereferencing operator. So anytime you are declaring the variable, you declare the pointer variable as a dereference using the dereferencing operator. That's the asterisk. But anytime you want to fetch the address of the variable, you use the ampersand to fetch the address.
Yes, sir.
All right.
Our network is breaking. Oh.
So let me take the last question from Gaffa, and then I'll go through something on the LMS with you. And yes, Gaffa.
Hello, sir. Thanks for the opportunity. Please, I wanted to know the output we have in the handout is different from the one your code ran.
Yes, so like I said, the outputs, especially for the memory addresses, the outputs differ. So you see that as for the 37, 58, yes, and the 58, wherever you see them, they are the same.
Yes, sir.
But the memory addresses differ. Like I said,
okay.
If I take the code and I run it again, the value will change.
Oh, okay. Okay, sir.
The values keep changing. The value of X is not that same value. You run it again and it assigns a different memory address to it.
Oh, okay.
So what it does is you use them directly in the program as and when you are running it. You just reference it. You just reference it. You don't assign it like not this one. We don't assign it like we've done here, like we've done in the code here. Like we say int x is equal to, no, you don't assign the address to it.
Oh, okay.
But you reference it. So it's not like you are going to say that, declare a memory address int star x or int star p equals, then you start writing some memory address xf. No, it doesn't work that way. Okay.
Okay, sir.
All right. So the values will change as and when you run it on your machine. It will not be the same as what you see in the handout, but it's just to tell you that anytime you see values in this form, they come as memory address.
Okay, sir. Okay.
Yeah.
Thank you.
You're welcome. Now they are in hexadecimal form. They come in hexadecimal form. Other alphabets. All right. I want to end here. I have to attend to something urgently. There's something on the LMS I want to talk about just quickly. We're supposed to have the quiz online, but attending to the continuing students regarding some end of sem project works I've given them. So we call atu.net.
No, sir, your network is breaking.
Oh,
So
please,
please.
is my network breaking?
No, you're okay. It's okay now, sir.
Yeah, yes, please. Sometimes.
Then sorry. All right. So I'll be adding some materials to the platform. Started with the videos. So those who are still asking for videos, when you go into the LMS, I've included the videos and materials. I'll include other materials, especially in the form of images. Okay. Just to explain some of the concepts. But some of these things, when you have a picture of them, you're able to appreciate them the more. It's easy learning them, especially when we get to control structures. I'll give you pictures. I'll paste them here that explain those concepts. But all the Zoom sessions we've had so far, the videos have been uploaded. This is the 5th Zoom session, so that'll be uploaded as well. Okay, so that you use them for revision. Now the the quiz, the reopening of the quiz is tomorrow evening at 7 p.m. Okay, 7 p.m. or is it 7:30, I think. Yeah, 7:30 to 10 p.m. It's going to be opened again, 7:30 to 10 p.m. So this time around, I've checked the questions one by one. So everyone can attempt it again. Okay, those who couldn't attempt for the first time and those who have attempted already will have the opportunity to attempt it again this time. What else? Yeah, so basically that will be it. So like I said, I'll upload some images here. I wish I have them here to show you how they look like, but I have to look for it and upload it. All right, so that'll be it for today.
Sir,
Yes,
please,
Wisdom.
for part-time student, tomorrow 7:30 we'll be having another class. So I was wondering, will the time for the quiz
okay.
go beyond?
What time is that class ending?
That class will be ending
at 9 p.m.
9 p.m. So full timers, do you agree we do it? What about on Thursday? Thursday, do you have a class after 7?
Yeah, we have a class.